Next on the docket, coming 87 miles south, John Senger from IDOT to talk to us about his chip seal demo and experiments. John?
Thank you, Phil. So when the National Center worked with the National Cooperative Highway Research Program to get the implementation of the new preservation standards out, Illinois jumped on the boat to throw out a demo project. But we took it a little bit further and kind of expanded some things within our specification that we've been questioning for years, and some of the guidance that our road township commissioners and things were offering that we weren't so ready to take up on. So we'll kind of get into some of that, and this plays well with what Todd presented earlier. So today we'll cover the design and the layout of the experiment and the entire project. Kind of go through some of the things that we had in pre-construction, and I'll show some pictures and videos of the calibration of the equipment. Then we'll go into look at the actual construction, and then we'll recap with some summaries of what we've learned, as well as what future work we've got planned for this project. All right, so this is a little small, but it was an 11-mile project, so I couldn't squeeze it into much more space. So we took, originally the plan was to take the 4 different gradations that we allow on our chip seals and place all of them. Little unknowns to me, there's one aggregate producer that makes a CA15 in the state, and that was about 200 miles away, so that was automatically out of the question. So we regrouped, we kind of threw out some other ideas, which we'll cover in the next upcoming slides. But essentially what we have is a single chip seal in the yellowish orange, well, they're yellow up there. Okay, so the yellow boxes, and we've got different gradations. We've got an FA4, which is our finer aggregates, a CA16, and a CA20, and then a final FA4 that was kind of used as a replacement for the CA16, or CA15, excuse me. Within those sections of those various aggregates, we also attempted to use a steel drum roller. This is what a lot of the locals say that they have used and they've had success with. We did not have that same success, so that is automatically out from staying in our spec, our future spec. And then we wanted to kind of take a look at the effects of the fog seal, not only on performance, but on friction numbers and texture and things like that. So those middle sections that are gray and hashed have a fog seal applied to the top of them. So we tried to line everything up so the steel rollers had 2 full sections they could roll over without moving beyond. The one thing that's not marked on this project layout, the eastbound direction was all cationic rapid set 2P, and the westbound direction was all high float rapid set 2P. So we basically tried to see if there was any inherent differences between the 2 emulsions, and we did notice some things. I'm not sure if it has any real standing or any real meaning, but we've got some photos to kind of highlight what we've noticed. Specifications that were changes from our normal spec based on our review with the AASHTO guide specs. So the steel drum roller is not in the AASHTO guide specs, but that was something that we wanted to just test and see what would happen. We ended up breaking rock on some of our initial sections, and I think they just immediately took it off the project and said no more. We limited our dust content on all gradations to a maximum of 1%. This wasn't as much of an issue with contractors I thought it was going to be. I thought there was going to be all sorts of hell raised, but they just said, they asked, you know, where we can find these gradations and which sources can provide it, and they went and got it. So that worked out very well for us. Once we get above a residual rate of 0.05 of a pound per square foot, we require that the fog seal be applied in both directions. So you spray half in one direction, turn around and spray the other half in the other direction. This whole fog seal operation has been kind of a pain with the contractor, so we'll get into that later. Pre-construction meeting, we discussed the roller requirements. We spec'd out that we wanted 3 rollers, and we had originally intended that it was 3 pneumatic rollers plus the steel roller. They took it as we want 3 rollers total. So we had 2 pneumatics and a steel. I wish we had 3 to kind of speed up the pneumatics when they were behind the paving train. Everything worked out in the end, but it's just a spec writing lesson for the future. Be very specific on what you want. We did clarify the aggregate requirements. The aggregates that the contractor, they didn't read the spec before they came in and bid on it. They were a little shocked to know that there was a dust content maximum of 1%. None of their original sources met that requirement, so we had to go back to drawing board and find them new sources. When we found out that the CA15 was going to be too expensive to basically bring on site, we did consider using a fractionated wrap as an alternative, just to try it out and see if we've got the same success that some of the western states are having with using wrap. That I think just kind of fizzled out once we gave them a couple different options on what they could use, and so they ended up changing over to a different FA4 source. So we completely changed that aggregate source and gradation on that site. Just as kind of an idea of what we're talking about when I say CA15 or 16 or 20 or an FA4, these are the normal gradations that we list. The contractor can kind of modify these a little bit based on their ledges and their sieves that they use, but generally they have to stay within these bands. So here's a couple samples. On the left we have a CA16, and I believe that is a crushed gravel. And then on the right we've got an FA4. I believe this is a crushed source as well. One of the other FA4s appeared to be more of a natural stone, which we'll see how well that performs. It's a little bit more rounded than I would have liked to see. But here's the other 2 sources. So this CA16 from Tricon, or it's actually from the Hennepin quarry, that actually qualifies as both a CA16 and a CA20. So they were using that as their CA20. And then the one on the right is an FA4 from Pekin Sand and Gravel. It appears to be a very hard aggregate, but like I said, it's a little bit more rounded for my liking. So we'll see how well that one pans out for us. Here's a picture of the stockpiles. Each one of the sections was probably about a mile and a half to 2 miles, just kind of depending on how things broke up with railroad crossings and intersections and things like that. So the stockpiles aren't abnormally large for what we would normally see for a 12-mile project, or 11-mile project, excuse me. And then hopefully these play. So this is just the chip spreader calibration. As you can see there, that real white spot on the left-hand side of his pass there, that was the first test. He obviously didn't like that weight of aggregate that was dropped, so they're performing a second test. The mat is actually directly behind it. So they'll run over it with a different gate setting, pull up that mat and weigh the drop rate. And that gentleman there is Mike Boyer. That was not part of the quiz though. He was actually a consultant that works with us, helping us on this project. All right, so here's just a clip of our I believe this is a CA16 and the CRS2P application. Sorry for the noise, I'll turn it down just a smidge. So I think we're within that minute time frame that Todd had highlighted earlier. Pretty close anyways. All right, so then here's something very similar. This is the high float. I believe this was actually with one of the FA4 aggregates. Here we can see that the chip spreader is lagging behind a decent amount. I think they had just done a stop to reload the spreader with a new truck. So the guy on the distributor truck kind of had a mind of his own. He knew everything and wasn't going to be told on what should be done and all that good stuff. So I don't know if you guys run into that or not, but it was a new one for us. All right, so one of the new things that I purchased when I started building our certification track down in Southern Illinois was a drone. So I've been trying to hit some of our research projects and things like that with a drone, just kind of get a different view on the project. So here the distributor obviously has taken off already. We're waiting for the aggregate spreader to reload with a new truck. This is my terrible gimbal move to look at what the rollers are doing. We got another truck backing up there. There's your all-in-one truck that Todd was talking about. Just passed by, or was right in front of that other truck. The rollers are pretty far back. I wasn't too pleased about that, but again, they only provided two, and one was smaller than the other. I don't know why that happened that way, but we won't cover this whole thing because I think this clip's about 4 minutes long. But once they got moving, the spreader was able to catch up pretty quickly to the distributor truck. So this project actually ends shortly after this bend here in the road up there. So this was in one of the sections in which we had an FA4, which the next slide here is a picture of the FA4 after it's been laid and swept. So as you can see, that's a lot more rounded than what we'd normally like to see. We'll see what happens with that. We'll monitor it pretty closely. Here is I should have put a big circle with the next through it. Here's the steel roller. This project had a little bit of rutting in the existing surface, which actually probably caused some more of the aggregate breaking and fracturing underneath the steel roller because it was spanning over those ruts and putting more downward pressure on the outer edges. So that's where we noticed a lot of the aggregate breakage. Like I said, I think they tried it on one section and then they took it off the rest of the project. Here's one of the FA4s. Here's the sweeper that we generally spec in our projects. And this was on the high float side. Here's one of the CA16s with CRS2P. When we put in the 1% maximum dust content ratio, the CA16 looked a lot better than what we've seen in the past. So I think even though this aggregate is not typically your one stone size, it might have some promise with that dust content limitation. So this is one of the CA16s with the high float. We saw a lot more bleeding or a lot more flushing than what we had seen with the CRS2P, especially when we ran into existing crack sealant. That crack sealant seemed to kind of help that high float flush a little bit more. So those were just some observations. You could see the crack sealant across the high float, and then as soon as it switched over to the other lane, which we had the cationic rapid set, that flushing was gone. So I'm not exactly sure what would be the cause on that one. So this project was kind of going in tandem with a research project that we've got going with the Illinois Center for Transportation to kind of tag into Magdi's question earlier. The University of Illinois, along with IDOT, is looking at a quality assurance test based on percent embedment. Here they're taking cores so that way we can take these back to the lab and scan them with an Ames 9400. The thought is that if we can define texture in a way that we can back correlate it to percent embedment based on the aggregate nominal size, we should be able to get to that percent embedment pretty quickly. This is our second year of testing on this project. The researchers think that they've kind of finally made a breakthrough, so hopefully we will be verifying the new test method with these cores as opposed to still working on trying to solve that problem. The intent is that we will just be taking field measurements and not actually taking cores to measure the percent embedment in the future. So it'll be a rapid test in the field that we should be able to come up with immediate results. So to kind of go over the project again, our plan is to continue research on the percent embedment and its relationship to performance. This project, knowing that we've got measurements throughout the entire length of the project, we can go back over year after year and continue to measure the texture and see how it's performing, as well as to mark the embedment changes over the years. We will continue to run texture measurements as well as friction measurements with our locked wheel skid trailers, just to monitor texture and friction throughout the life. And then also we will have this captured every other year for distresses and cracking and things like that. The hope is that we'll be able to notice a big difference between the sections that were fog sealed and that weren't fog sealed on chip loss and things like that. So we've got a lot of work ahead of us, but hopefully this will give us some good insight into how to shape our chip seal specifications in the future. Questions?
Hey, John.
Yes.
Was there a certain PCI that you were looking at for those chip seals?
A PCI?
Or just pavement condition index?
So before we applied?
Yes.
For our chip seals, we try and limit the distresses to very minimal cracking, especially a single chip seal. Once we get into maybe a double or a cape, we're a little bit more lenient. But as far as a particular PCI, we don't technically use PCI in Illinois. So it'd be a condition rating survey of somewhere between 7.4 and 6.0, I believe, which really limits the cracking.
John, my question is just on the fogging.
Yes.
So we've been fogging our chip seals. We find that after about 2 winters, it's pretty much gone. Are you monitoring your fog seal, and will you be reapplying?
So we will be monitoring the fog seal. I don't know, I've not spoken to the district about reapplying. I do agree that it's best practice on previous sections that we've applied fog seals for experimental purposes. We noticed the same thing. I'm hoping with a little higher rate that we might get a little better lasting power, but we have to kind of balance that with friction numbers and safety and all that too. So it's a balancing act there.
Yeah. Okay.
John, it's just a question again on the fogging. What was your rate of application and what type of oil are you using?
So we originally spec'd out a slow set, so that way we can allow the moisture of the existing chip seal to get out. We also require that they wait 48 hours after placing the chip. So everything that we do in Illinois for fog seals and tack coats is based on a residual weight. So the residual that we use was 0.05 of a pound per square foot.
So I noticed you have 4 different types of aggregates or gradations. So when you put this work out, do you specify types, or you essentially say, I need a chip seal?
So the district actually is supposed to specify the type of, the gradation of aggregate that they want in the plans, and that's how we did it. So everything's included in the spec, but the spec requires that that detail is called out in the plans.
Let's hear it for John.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.